Okay, good afternoon, good morning, and good evening, depending where you are. Welcome, everyone, to the Asia Solar Energy for Climate Change Conference, a platform dedicated to harnessing the power of renewable energy in our fight against climate change. The conference is organized by Carbon Care InnoLab. My name is Ken, and I'm honored to be your moderator for today's panel discussion. Today's section will be focusing on circular solar economy, sustainable end-of-life management of PV system. So, as everyone knows, the PV market is growing rapidly in the last decades, especially in Asia, where think tanks such as Amber Energy estimated a 22% growth each year back in 2022. However, if we are evaluate the effectiveness of a clean energy in a life cycle point of view, the end of life management is an essential element that we just cannot leave out. Without a proper end of life management, discarded PV could create environmental hazard, including toxic material leaching and resource wastage. And so today we have four extraordinary speakers joining us today to explore the circular solar economy and sharing their vision with us. First up, it will be Mr. Feng Jinglei. Jinglei is the Program Officer and Policy Advice in the Knowledge, Policy and Finance Center at the International Renewable Energy Agency, in short, IRENA, focusing on policy for the deployment of renewable energy in end uses. Second, we have Mr. Komfakin Patanachai, or Ruth, which is easier for me. Ruth is the General Manager in Thailand for the Albert Group Asia Limited, with 25 years of experience in waste management and recycling, specializing in WEEE, plastics, MSW, and waste to energy. Third up, we have Dr. Tanvi Bansai. Tanvi has led a range of academic and industry consultancy projects across solar energy, quality management system, supply chain optimization, and RFID tag application. As the founder of Circle PV Limited, a company dedicated to develop a business-to-business solution for solar waste in Hong Kong and Asia. And lastly, we have Ms. Ivy Leung. Ivy is the Executive Director of the Carbon Care InnoLab, committed to engage stakeholders from all of societies to enhance the public's climate resilience and advocate to policymakers on the direction of mitigating climate change and promoting climate justice. Welcome, all four of you. And without further ado, let me invite Jinlei to share first. So Jinlei, you have the floor.
Thank you very much, Ken. Let me first share my slides. So first, I would like to thank Carbon Care InnoLab for organizing this amazing event and also the invitation to IRENA. So my name is Jinlei Feng. I'm the Program Officer on Policy Advice at the International Renewable Energy Agency based in Abu Dhabi. So at IRENA, we support all member states in promoting the sustainable use of all kinds of renewable energy technology. So our work covers different aspects of the renewable energy, including the circular economy for that. So today I would like to very briefly to share some of the IRENA's ongoing work related to the circular economy for solar PV and also policy recommendation related to the end-of-life management. So first, I would like to give some background why we talk on that. So from IRENA, based on IRENA's data, we see that by the end of 2024, The global renewable capacity, the total installed actually has reached 4,443 gigawatts globally last year. So the total installed power capacity, almost 44% has been renewable. And if you see the last year, the total newly added power capacity in a single year, actually 91% is from renewable. And if we look at the different technology, and the largest share has been solar PV. And if we look at the last 10 years, from 2015 to 2024, the 10 years, the global capacity of the installed solar PV increased from just 220 gigawatts to over 1.8 terawatts just in 10 years. And it's not only just about the energy, we also assess the socioeconomic benefits of this sector. Last year, actually, renewable energy has provided over 16 million of jobs, and the largest share, almost 44% of the jobs come from the solar PV industry. So the largest part come from Asia. Almost over 60% of the PV panels over the world has been deployed in Asia. And this includes, we have seen very positive trend deployment in not only China, India, but also the Republic of Korea, Japan, and also many of the Southeast Asian states. So we also check what it looks like in the future. If you look at the future, IRENA, we estimate that if the world would like to achieve the world targets aligned with the Paris climate target, renewable capacity would need to increase to over 11 terawatts globally in the next 5 years, and also over 30 terawatts by 2050. And almost half of this needed renewable capacity will need to come from solar PV. And of course, if you look at the right side of the figure, you can see not only China, India, Indonesia, but also many other Asia states. The Asia will contribute to the majority of all the needed solar PV capacity. If we look at the deployment, one indication is that the rapid deployment now and in the future will have strong indication about the material demand. So the material is that it's not only the material of the cover for glass, but also the silver for the cell production, but also the copper for cable, panel, and aluminum for the paste and frame. So we had some kind of estimation about how the material demand looks like in the future and in the past. We compared 2015, 2014, and 2020, the material demand for the deployment of PV globally. Even though in the 6 years, the PV efficiency actually advanced 20%. But the overall material demand, the weight of material for producing this has been doubled in 6 years. And if we see in the future that by 2030, we estimate over 20 million tons of this kind of material showed in the figure will be needed for producing all the panels. This is only a conservative estimation without considering the loss of production. And if you look at the whole material demand for all the industry, the share is not big. But we also notice the share used by solar PV industry has been increasing. If you consider all other energy transition technology, the EVs and all grids, the pressure on mining will be increasing, and they have very strong implication on mining and link the environment footprint. Apart from that, another topic is about end-of-life management. I would like to only highlight some key points on that. We estimate that global end-of-life solar PV currently still not huge, because usually we see a 30 years, at least the lifespan of the PV panels. But by 2035, globally we'll have over 12 million tons of PV, end-of-life PV. And the number will increase to over 210 million tons globally by 2050. And the majority of them will be from the China, US, European Union. If you look at 2040, in just a single year, the PV panel waste will be over 8 million. And around 30% will come from China and other Asia countries. And so question is how global and Asia countries will manage these challenges. So circular economy actually is the most promising solution to address both the two challenges related to the material demand, but also the end-of-life management. A lot of discussion already mentioned, so I would not repeat here because other experts will introduce more concrete example on this. I would like to only highlight two messages. Reusing the component of solar panels, such as the wafer, can bring actually very promising return for the industry player. And also another key point that's not being given enough attention is circular-based design of the panel of the technology, which means not only the efficiency, longer duration of the service time, but also minimize the use of hazardous material for that. So only recycling the panel, let's say by 2050, the major material will create over $20 billion of the market value. So, but we see that there are many barriers. The barriers may be relevant to technology, but also the costs or information. Some of the policy and measures already used by some countries, like the National Strategy used and the Extended Producer Responsibility by EU, and also ban of the landfill by Australia. And also, of course, the data and the information is still a big gap. So this needs some international collaboration to address, but also we see that, as mentioned, for reusing and other, that the international collaboration to build the standards and the certification system also a big enabler for that. So to summarize my point that global energy transition requires a rapid increase of all renewable, in particularly the solar PV will play a major role. So this brings challenge related to the material demand, but also end-of-life management. So circular economy is the most promising option. Technology solution already there, some of them are already there, but the barriers remain many. So policies are needed to address these barriers, incentivize the stakeholders to and promote the wider adoption of sustainable practice. So I will stop here. Thank you very much.
Okay, thank you, Jinlei, for sharing the global landscape of the renewable energy, PV panels usage and forecast for us. And next up, we will have Ruth, who is actually working in a recycling landscape. Ruth, you are up.
Sure, thank you, Ken. So you just see my screen now. So I would like to start the session with the contrast picture compared to the topic we discussed today. So this is the picture I took when I do visit the community of the e-waste recycling, and I saw that starting to have also the PV there. The photo is the the open dump site, which is located in the northeast part of Thailand. So I think this picture is telling that quite obvious this is the completely informal sector and also illegal as well. So before we go to deeper to that, I would like to bring you to see the overall picture of Thailand first. In Thailand, you can see on the left-hand side for Thailand map, and the color it show you the density of the EVS generations, and in the pie chart it show you the proportion. But the highlight here is that in many study it only presents around 430,000 tons per annum of the EVS generated in Thailand. But actually, what they're mostly missing is another 230,000 tons, which it came from the bulky use and also industrial and the commercial size, meaning that totally actually Thailand generate more than 665,000 tons per annum, with anticipate of 3 to 5% growth. I know actually it's quite the outdated number, and today we can see that it's actually much higher than that for the year-over-year growth. And in Thailand, it go in the same trend of the global that the generation of the EVS is exponential, including the PV there. And unfortunately, that the percentage of the purple recycle even decreased, come down from 22% to 30% or even less. This is the quick overview for Thailand. And specifically for the PV, same as we know that exponential growth. So today Thailand already installed for the PV panel more than 5,000 megawatt, which is convert to more than 12 million of the PV panels. And in Thailand, we predict that in 2057, we will have more than 600,000 tons of the end-of-life PV in Thailand. This is the challenge. Why? Because of actually Thailand today is not really have the infrastructure in order to handle those. So in order to promote the sustain for the end-of-life PV, first, I think we need to understand how the value chain and how the end-of-life PV move, which is I bring this picture of my study on the WTPE, and I do believe that the PV is going to in the same value chain. Start from the left-hand side, the waste generators, it came from the two sectors. The first one from household, which is the majority, and the second part, it came from the business and the bulky use. So 665,000 tons is delegate into 4 different waste streams. The first one in the formal, and the second one informal, and then bulky use B2B, and then the through the donation, charity or campaign. So you can see it's kind of back and forth, but I try to simplify this as much as possible. So you can see, let's bring the first one first. For the formal, 40% it will end up in landfill, and 60% it go to the junk shop. I put here the logo of the Wong Panit, which is the represent of the biggest junk shop network in Thailand. And you can see on the right hand side, most of the end of life WTPE, which is including the PV as well, it came to informal for simple dismantling and also in compliant environment as well. And only small portion it came to the formal recycler in Thailand. This is the overall of the how is the PV move along with the other WTPE. So my purpose, how can we sustain, is that we can see it from my previous slide that we for informal sector, they have a massive of collection power, and they have the better position to access into the materials. So I think it makes a lot of sense to involve them, try to bring the informal into the ecosystem, and also design the policy approach. I think it's really difficult to promote the sustain either PV or WEEE in sustained way without involved informal sector, because we hardly to how to say ignore and also eliminate them, such a developing country like Thailand. So I think it's better to bring them in and try to elevate them, like I put the photo in the bottom, and transform the in compliance environmental work into the more in at least minimum of the compliance work environment. And apart from that, I think the business model to have the bankable project is the another hand of the big challenge in order to start this kind of chicken and eggs, because if you set up facility first, you don't have the sufficient of the input. This is the most challenge. When we come to the recycle industry or business, the first question either you need to recycle any kind of material, plastic, glass, or e-waste or PV. The first question is how much the volume, right, you can collect. So the idea is it makes sense to design of diversify of revenue, diversify of the input, and the process have to be flexible enough in order to adapt to receive of the different kind of the materials, because number one, you in the e-waste recycling business, it's hardly to predict the input, and even you can predict that still how do you say, very high fluctuate as well. For example, if today we set up one plant and have one line that say can treat around 20,000 tons of PV, you can easily to see 1 week you can run only maybe 1 or 2 days, and the rest no input and no production. Then hardly to make the bankable project. This is come up with this kind of model to have diversify of the processing, which it can be simply to integrate. I show you in the top. It's designed to have the simple dismantling for the general WEEE, and then we have the core line for the PV as well, and additional to have also the coming up a potential of the e-waste, which is the lithium, either from the small V or came from the EV. And then of course we know that the mode of the model makes sense is that to reuse first. That's why in the next step is to check the condition of the equipment we receive. If the condition is good enough to refurbish or even can reuse directly, it's better to reuse to minimize the waste. And then if not that good condition, we go to the different kind of dismantling. And in order to make the project is more sustained and also bankable, I think it makes sense to adding the downstream process by address the leaching to extract more purity of the value material, and also maximize the value of the material to have the higher the revenue, if that the how to say, the equities of the project is available. This is the ideal of process that I propose to ensure not just sustain in terms of environmental, but also in terms of business long run, to have diversify of the process and revenue stream. So in addition, the challenge, as I mentioned already, in Thailand, we don't have the sufficient infrastructure. And then the photo I took, and also many of the solar farm is like it. The user is not really well prepared to aware on that how impact of the end of life PV solar. That's why they put the end of life on the floor directly to the soil, which is, you know, that it had easily to harm or contaminate to the earth, and also the model of that to disposal in the proper way, and they need to pay for the collection fee or tipping fee also is really emerging in Thailand. This is the challenge. And one, in addition of that, the challenge is that, again, back to the informal. So not all of them can come to the dismantling, but still many of them, which is the efficiency of PV somewhere like 60 or 70%, right? That already has been reinstalled. It go to the black market for reuse. It sounds good because it reuse, no need to scrap it, but the challenge is that when is the dispatch to Second Life go to, for example, to the farmer and so on, it's hardly to collect back because it already generated in many locations. This is the challenge to take them back. Otherwise, we will see the PV end of life end up at the landfill. So this is the summary that I already mentioned, and yeah, I'm happy to have any question. Yeah, thank you.
Thank you, Ruth. So next up, one thing I forgot to mention previously, if you have any question, please feel free to type it into the Q&A section, and we'll address them all together at the later part of our panel discussion. So next up, it will be Dr. Tanvi Bansal. Tanvi, you are up.
Thank you. Can you share my slide?
Yeah, hold on for a second.
Seems to be, we have question. I saw you had raised hand, right?
Oh, while we
to
are
me or not?
while we are sharing Tanvi's presentation, Ivy, do you have a question?
No, I guess it's like the technical.
Okay.
Yes.
Okay.
Okay, cool. Tanvi, you're up.
So can I start? Yeah. So hello everyone, this is Tanvi, and I am just to give a brief introduction that I am the founder of Circle PV Limited, initiative from Hong Kong. And our initiative is that circular solar panel waste management, which is the need, and I will be convincing you through our slide what is my experience and why this is the need. And talking about the Circle PV Limited, our aim is to build a B2B platform for solar panel waste management, because apart from other things, this is the main requirement which need all supply chain links to be connected on one platform so that this can be done effectively. So yes, I will be taking to next slide. And we are being supported from local stakeholders. So local PV stakeholders are there with us. University experts are there who are back supporting this to develop. So starting from the first slide, I will be taking you that the solar panel has many layers. And of course, in that layers, why and what is important is that we have glass, we have plastic, we have aluminum, silicon, and metals like copper and silver. So of course, PV trends are changing very means in the coming future, all the manufacturing trends are changing. So what lies right now will not be true for the next 5 to 6 years. But the question remains is that if we talk about the solar panel waste, we are talking about the solar panels which are 10 years back from now. So the main technology for the 10 years and 15 years back solar panel from Hong Kong or maybe anywhere in part of the globe will be prevalent by monocrystalline. So that is something which is there. And then we have rooftop, of course. So talking about these two technologies, silicon and thin film. So we have 76 to 89% glass, 10 to 4% plastic, which is, of course, nobody talks. Aluminum, 8 to 6%, 5% is silicon, but important because it is a critical metal. And then, of course, metals like silver and copper, which the manufacturing industry trend are trying to reduce. So we are hunching for to reduce the cost. And what it is going to take, I will be discussing later on industry trends. But this is about this. And then, of course, the carbon footprints. So we know that glass has its own carbon footprints. We have this in a bulk in solar panel. And then, of course, we have most carbon hungry can be the plastic and aluminum. Of course, aluminum is most missed because 7 to 20 kg CO2 carbon emission per kg. So we need to think about that, if not in the toxic or hazardous material which I have listed down here to the right means toxic metals and hazardous metal. So people are generally going to argue that it's not that much harmful for the environment because it's not in that much percentage. So my question is that if not hazardous and toxic, but it has its own carbon footprint. So can we reduce it? So we can reduce it by using the solar panel waste management. That is how to bring you to your notice. And talking about some industry trends, so I will take you to the technical side of it. So what is going to change in future? So increase in solar wafer and module size. So we are trending. So initially it was 182 wafer. Now we are changing it to 210 mm. So result, the solar panel are going to be bulkier than before. And what is the impact of that? That, that during logistics and transition, because I was India lead on quality management of Indian German co-consultancy project. So I know that these things are matter because that when we received solar panel from one region to another region during the transportation itself has some issues which nobody talks about. We talk about only the end of life solar panel. So of course, these increasing trends are going to be very critical for solar panel based. There will be installation, loading, packaging due to this bulkier panel. And of course, it will become less compatible with the existing testing lines. So then of course, we need to think about. So then second is thinning wafer. Wafer is also thinning because we want to make it we want to reduce the cost. So it is reaching from 160 micrometer to 40. So that is again making our solar cell very brittle. That while testing, I know that I have the feeling that it is very brittle. So when it goes into the installation sites, of course, it is going to be an issue in the future. Thinning glass. Our glass is also, solar panel glass is going to get thinner and thinner, 3.2 mm to 2 mm. So again, these are the issues which I want to bring to your notice, can be alarming for the future industry trends. Next, I can go. Yeah. So here the supply chain B2B links where when we talk, so I would like to discuss that how and why it is important. So talking that life cycle damages and key stakeholders and the key challenges about it. So talking about first manufacturing stage. So we have, during manufacturing, lot of waste occurs. But of course, thanks to China PV industry, which is of course trending towards how they can reuse their waste into their manufacturing. So that is something which is going to be a trend. But yes, the manufacturing waste is there. Another waste which is due to the quality rejection. So we are going to be supported by our Sinovoltaics, which is on this quality testing. So they have shown us that before going into the actual installation site, it has a lot of quality rejection, which is going to be on the manufacturing side. Then of course, we have customer warranty return, which is going to be in the warehousing of the factory or manufacturer. So that is the story from the manufacturing stage. Then coming to the transportation and logistics. So of course, there are transportation and logistic mishandling errors, although very less, but it is there. Yes, installation stage is the third, which has the maximum. So of course, installation errors can be less, but it is there. Extreme environment event. So Hong Kong is the good example of typhoon-based extreme environment event. And technological advancement, of course, we are trending for the new technologies. Then, of course, all the panels are going to be obsolete. End of life panels is, of course, end of life means which is stated 25 years. But is it real? That is a question. So underperforming panels are there. Means if you think that you are not reaching to your expectations, then you will be thinking to change it to the new technology. So that all goes into installation stage. So of course, I have given you one data which is showing 71% comes from installation sites, then 22% comes from manufacturing side, then 7% is other regions or other reasons where this transportation, logistics, and other errors can be there, which goes into this category. Then key stakeholders, of course, because of these stages, manufacturers, installers, suppliers, we have recyclers, construction and real estate industry, commercial and residential industry. What are the challenges? Of course, as you said, and I think you have shown in your slides that we are going to adopt more solar energy. So of course, with the increased adoption, EOL waste is also going to increase with the solar growth. premature early waste. So of course, Hong Kong is the good example where we have frequent typhoons in Hong Kong, which reaches up to, means lastly, it reached up to 150 km/h. So our solar panel, are they ready for it? No. So I will be showing you the picture which happened in the last few years because of that. And old solar panels from 10 to 15 years from now, of course, they were not able to withstand this heavy typhoons, and it's going to increase in the coming decade. So very alarming. Environmental factors like high humidity, heat, and UV radiation accelerate PID, corrosion, and delamination, shortening the lifespan as stated, which is 25 years, but it never reaches to that. Before that, you will be experiencing a lot of underperforming issues. So that is again very important for Hong Kong because we have this UV radiation, heat, humid climate. Lack of waste management and recycling infrastructure because we don't have standards and policies. So recycling infrastructure we don't have. Although ELBA has that, ELBA from Hong Kong has that some of the electronic, very advanced electronic industry, electronic waste processing industry, but then they need the support of infrastructure, means standards and policies. So that is lacking from Hong Kong. Lack of standards and policies I told. So that is also the part of this. We can go to next slide. Yeah, so this is some disturbing images which I showed, and this is from Hong Kong. So just to give you one evidence, we are going to have this, which is going into landfills, into sea, and solar panel is going into the air. So it is very dangerous, of course. So this is the story, which is the evidence that this is happening. Then, of course, some theoretical model which we have built, which is based on linear assumptions. So the data can be overestimated, can be a little bit deviate from the from this, but linear assumptions are that we have typhoon damage, we have EOL panels, we have UV based degradation and humid climate. So all this goes into the Hong Kong solar panel waste assumptions. So the important part is that as we are growing we are growing to the solar growth, means from 300 gigawatt to some 800 gigawatt if everything goes linear, then of course the solar panel waste is increasing, has been shown from the red bars, giving you the idea that how and how this is going to increase. So with current projections, so it is like can be 80 to 100 tons, and it will be reaching 500 tons up to next 10 years. Why I have chosen the 10 years? Because you know that it will be critical for the Hong Kong on the adoption of solar policies. And if I'm not wrong, because our solar tariffs are going to be revised after 2033. So of course, this is the time we need to think and we need to invest on this. I think, Ken, you would be agreeing on that. So this is the time we need to think about that, how we are heading up to in terms of waste, in terms of solar adoption. So it can reach up to 500 tons up to next 10 years. That is on the theoretical basis. But then according to a 2019 survey from Ecotech professionals from Hong Kong, they have reflected that the waste is going to be much more than, because you know that there are underperforming panels, there are low quality panels which will be in the market. So that can go from 1.59 million to 2.38 million old solar panels in the next 8 to 10 years. That was the prediction from 2019 survey. So just to bring you what can happen in the next few years. Yeah. Next slide. So this is what we are promoting, circular solar panel waste management. Why it is important? Because you know that before solar panel going into the recycling. So waste management, always we think that it is the recycling, but it has a lot of dimensions, so which we are promoting. So here the circular solar panel waste management, how it works. So it can be the link which we are trying to promote as Circle PV Limited. So it can be sitting between installation sites and the actual recycling sites to facilitate this whole waste management. Because the problem with the waste management, not in the solar, but also other waste management, is the cost, upfront cost, you know, that people are not ready to provide to give that much cost. And of course, solar recycling industry, as mentioned by previous speakers, is very cost hungry. It needs a special machines, so which is not available in the Hong Kong. So a special machine means that cost is there. So people are not willing to take that up. What we can do, that we can facilitate this infrastructure. What it can promote the waste prevention first. Second, with waste reduction. Third, it can promote repair, reuse, recycling strategy, which people don't know right now. People don't know what is the stage, when they need to repair, when they need to reuse, when they need to recycle. We always talk about the circular strategies, but we don't know the stage. So how we can facilitate that? Then, of course, fourth comes the compliance and standards. So, you know that for the solar panel waste management, solely right now, the only available standards in the market are the R2V3. Then other than that, they talk about the electronic waste management. So of course, it is important to understand that the lacking of this. So these are the all compliances which can be handled by the circular solar panel waste management. And the key benefits are the enhanced ESG performance, waste management, reduced cost, access to connected B2B network. If we are all are connected, it can be done. Cost savings because through access of recycled material for repurposing. Yes, so this is about the circular solar panel waste management, which we are promoting. Yeah, next slide. Yes, so talking about our vision, I told you that we are performing, we are just creating B2B network and looking for the support. And what will be the key scopes of that? That we will be developing AI-informed waste prediction, repair, reuse, recycle decision, which is crucial for waste management. So of course, and for solar panels also. Collection and transportation, yes, we are talking that for the partners, local recyclers to help us on that, because it needs, because it is not one man's responsibility, it is all the links which needs to provide their support in this. Then, of course, people don't know what is the recycling worth and the accuracy after the recycled material. So that is also important. Is it really worthing? If we are saying that recycling can give us the glass, the silicon and this, how much it is accurate? And can it be repurposed? So that is all which can be, which people want to know. And this is the part of this. Solar panel dismantle at local recycling center is also should be in accordance with the standards. Key B2B network is, of course, this is all the part of this. Standards and certification support. What is the standards which needs to take care of all of this? And then ESG and LCA support, that if you are managing your waste, how much you will be benefited. So that will be all part of Circle PV Limited scope, with the support of the partners from here, and of course calling out many. And what you can expect, of course, we have ESG goals, which you can expect that you will be taking care in your sustainability reporting. If this kind of mechanism is going to be on market, so we can manage 80 to 100 tons of waste, which can be managed. Material recovery rate from the recycling can be 90 to 95%, of course, with the plus minus, because we are still upgrading on it. We are managing on it and researching on it. 1200 kg CO2 savings per ton we can expect, and of course some cost savings if it is being repurposed and reused back into the manufacturing, that can bring 24 to 25% cost savings. That is there. Yeah, next slide.
Okay, thank you, Tanvi.
So that is from my side, and looking for the support, and of course the questions you can ask.
All right, thank you, Tanvi. So next up, we'll have Ivy. Ivy, you have the floor.
Thank you, Ken. I mean, like, the three speakers have been sharing so much insights and a lot of resourceful data and figures and also technical basis. So I probably will not like jump into all those details. Instead, I would like to start with like why CarbonCare InnoLab as an NGO civil society, that we are so concerned about the end of life management of solar PV and the circular economy. So the first thing is mainly because that we won solar care programs. We get the money from the philanthropy and corporates to fund us building the model with all the other angel partners that are interested in building solar PV systems at their open space, rooftop, or like anywhere that they feel like there is a room. how we actually start the model is mainly because of the feed-in tariff the Hong Kong government has been offering for us until 2033. And then I would briefly go through the figures that we have. So for now, we have around like 34, I think like it's the figures of last year. So we are actually building up, and then we estimate by the end of 2026, our PV system sites will build up to 40 up to 50. And we have been observing that because of what Dr. Tanfi has been mentioning, because of the weather, the extreme weather conditions in Hong Kong, there are quite a lot of panels that the lifespan is much shorter than what we expected or what it claims. So it actually come to us that we are really kind of like in the need of sorting a really sustainable solution for our solar PV panels. And what happened now in Hong Kong, I mean, like Dr. Tanfi has mentioned a lot and also provide a lot of figures, so I probably skip those parts. But I mean, like in Hong Kong, we also have a e-waste policy, but then the producer responsibility scheme mainly only focus on the things that happen in the slide, like air conditioners, refrigerators, washing machines, those kind of like domestic electronic appliances, and also some of the electrical thing, mainly covering like EV electric vehicles, batteries. But then the solar PV systems have never been mentioned, and also not in their agenda to talk about how the recycling need to be handled. So no legal guidance, regulations, or target has to be done. And then also there are no public facilities available to connect the panels. And then we have been recently studying on the United Nations Development Program, which they have also launched the Solar for Health program for some years, starting in 2017 in Africa. And they also have document on the handling of the annual life for this project. But the main focus that they have been talking about are on the regulation and also the infrastructure. The challenge is that the PV panel disposal regulations is actually not widely considered and even not implemented in most like more developed countries, I would say. So it actually comes to us a very big surprise because many of the countries that we have been seeing is that we imagine because some of the countries in Europe have been doing that like for many years, and then we are expecting that they have a more mature end of life management. But the real case is that it's actually not the case. So I think the main problem is that we are like trying to find a reference that is a good reference that we can follow no matter when we're talking about regulations or infrastructure. But then the problem is that it's actually not the real case. And this United Nations Development Program has also like indicated those challenges have not been tackled yet. So we're trying to find out like other solutions. And then under the solarbestpractice.com, there have been like laying out the second life opportunity for the solar panels and the PV waste challenge. So currently, if we talk about after the dismantling or the damage of the solar PV panel, no matter like if it's like kind of like under no matter what reasons called that end of life, it will either be going to the waste path by recycling or disposal, or the second life of repairing and reuse. But the current mainstream options mainly go to the recycling and disposal discussions, which we like have heard from the previous speakers talking about the toxic and also the dangerous components of those PV panels. But then when we talk about the potential of reuse, there are actually a lot of room that when we really want to explore a sustainable circular economy, is there a secondhand market that worth us to see if there are any components or even some outdated model of PV panels are worth us to understand the potential to explore if there are like any kind of like off-grid solutions. Maybe some of them can be like helping with public lighting, some of the irrigation systems, or even e-bike charging, because those are the things that they do not require a lot of energy output, but then it also can supplement from the solar PV benefits. And also, there are a lot of like potential that we can consider about if there are any old systems that we need to think about repairing. Technology that we haven't been talking a lot, because from what we now have been doing is mainly the way that we have been working on is to like whenever there are like damages, whenever they are kind of like old model, then we will think about replacement instead of repairing, or the advancement technology that we can actually look into, which is a really important part for the circular economy for us to look into. And then, of course, like after talking about all this, there are still a lot of uncertain areas. So, for example, we want to explore, like talking about the awareness and also the knowledge of end users. Do they like, if you own a PV system at your place, are you aware that you have to handle the panels properly? Because many users, they only like look at the investment place from knowing that the solar PV have been generating a lot of like energy, have been like worth the feed-in tariff, but are they aware of the dangers and also the risks behind a poor management of the solar PV panels after they are dismantled? So this is kind of like the first step of awareness building. And then the second part is about which responsibility it will go to. So for example, for us, as the user and also sort of like in the role of an installer, we have been like really trying hard to call on our manufacturer to come and then do the sustainable and responsible recycling of the panels. But then ultimately, are these responsibilities belonging to the manufacturer, the installers, or the end users? So who will take the part and take the lead to help on this? This is a still very uncertain questions. And also, if we rely on the manufacturer to help on the sustainable recycling currently, are there any way that we can ensure that the panel are actually being handled like with safe disposal or storage, or even like the recycling quality control, who are actually monitoring all this? So there are actually a lot of questions and doubts behind the handling of the end of life. And also, we have been hearing a lot of concerns about the cost of recycling or reuse the panels have been really high, and then they just tend to dispose them because of the like cost behind it. And will there be kind of like technology advancement that will help the situation, which is still a very big uncertainty? I mean, like time's kind of winding up, so I'll stop here, and I'm sure that we have more insightful discussion or questions that we can bring along.
Okay, thank you, Ivy. So, thank you all for panelists for their insightful presentation. As we can tell from the presentation, we are always talking about how much solar waste will there be in maybe like 2040, 2050, which sounds quite far away from now. But actually, we all know all those infrastructures and all those policies doesn't appear in a snap. So actually, maybe this is a right time to start our discussion for all of them. And as we touched before, most countries, especially in Asia, do not have a policy for solar waste yet. So my first question will more likely be answered by Jinlei and Ivy, is that since we need to start developing we need to start advocating the policy to the policymaker right now. is there any what will be the most critical one that you would like to propose to them first? And the second question is, even for countries that do have policies, for example, Japan, where PV Cycle Asia office is based, some people still consider leaving the damaged system as is or throwing them into the forest is much cheaper than recycling them. So is there any other policy you think would be worthy to encourage people to dispose the PV system more properly? For example, maybe both of you mentioned the producer responsibility or maybe government incentive. So these are my two questions for maybe Jinlei and Ivy.
Hello?
Hi, yeah, I heard you.
Yes, maybe I would like to give some feedback on your question, because actually it's a very, very important question, not only for Asia, but also for many other countries who has been planning with their solar PV ambitious targets, and all the policymakers, but also industry. So I would say all the countries actually they have very different contexts. Some countries, so the policy would need to consider the local resources. Resources mean that their financial, but also their industrial resources, and also if they have all the stakeholders who have the expertise, like Carbon Care, lab that can provide a very important role, not only the industry but also policymaker. So usually what we propose is first, if you look at the measures what policymakers can use, is usually examples from the European Union, like expanded producer responsibility has been widely provided that, okay, it can be a starting point to start prepare the overall framework on that. But the key point is they need to define clearly the financial responsibility on this, the financial responsibility on the collection and treatment on that. That's the most important part. But also, if you look at different other places, like some states in Australia, they are very good at promoting the ban of landfill on the solar PV. In that way, they can help to drive the local stakeholders and the industry to thinking about how to build all the needed infrastructure. But I think I would like to also reflect one of the question raised in the Q&A session by the audience
Yeah,
that's regarding. Yes, actually, another point I would like to mention that regarding question is the key point is not only policy but also the industry. Because all of the discussion, especially if you look at countries where labor costs can be very high, the industry they don't see a promising return from the participating on that without the regulation, restricted regulation or something. But if you think about long term, you need to think about what's the incentive for all the industry players. They join this framework and take their responsibility for that, not only the recycling, but also reusing. So this is about the drivers we also need to think. So in that way, it touch not only the cost of the processing of the treatment, but also if you look at the informal, the expert from Thailand mentioned very good about the informal, because the informal treatment, not only solar PV, but also electronic and electric waste is common of the world, is that they cover the majority of the activity, but they do not necessarily take into account of the cost of the environment or public health. This is some key point all the policymakers need to think about, but also provide the financial incentive for industry to join this and to make this sustainable practice more cost effective, so it can expand by itself after based on all the framework. So maybe, yeah, I will stop here. Thank you.
I think I agree with the part about the incentive very much, because it's just when you first start to launch about renewable energy, people have been really hesitant on it because of the high setup costs at the very beginning. And that's why a lot of the governments have been introducing feed-in tariff at the beginning, because they want to encourage people to see it in a very long-term investment perspective. So I think it's actually the same for the end-of-life management of the solar PV systems. For now, because the technology and also the infrastructure have not been matured, it means that a lot of investment have to be done at the as the setup cost. But after the incentive provided, maybe some subsidies from the government, and then encouraging the industries to start looking into the technology to advance in it, it means that from maybe a few years, things will change. And then they will also see the financial benefits that can be generated from the huge amount of the solar PV panel that are going to be outdated. But now, if we do not do anything on it, and then waiting for 2030 to approach, it will be really dangerous. And also talking about subsidies and also talking about regulations, which is really important, because I think being the manufacturer of the solar PV panels, they have been benefiting from this economy for quite a long time. Are there any regulations that we can actually advocate for different governments to consider that the solar PV panel manufacturers have to be responsible for part of the recycling or the reuse financial model afterwards? That will be something that really help the solar development in the long term.
Okay, thank you, Jinlei and Ivy, for your insights. And thankfully, you both mentioned about the producer side, because that will be my next question. First of all, there's a question in the Q&A section for Ruth, which is, hold on. How can formal waste treatment facility collaborate with informal collectors and dismantlers to achieve national recycling and reuse goals? And I would like to add a little bit and extend the question to Tanvi. So not only besides the how, since we know there are quite different kinds of solar panels, which Tanvi mentioned about, well, we mainly have monocrystalline, but we still have something that's we have thin film, for example, like cadmium telluride. We have some older panels which will be polycrystallines. So in terms of recycling facilities, do you have well, besides explaining how the informal facility helps you, do you need extra infrastructure in order to handle those recycling? For the first one. And second one, do the volume, we all know the volume will be skyrocket in 2040, 2050, and 2060. But do the volume right now support the argument for you to build a line for these recycling? These are my questions.
Okay, sure. So first of all, to be honest, we're not successful yet in order to involve the informal sector. But to answer your question, also we try to do now, and how to do that is to address some incentive to informal sector that that motivate them enough to deliver the PV or e-waste that they have been collect and ship to us. And what they can do is maybe just do simple dismantling without touching or in any hazard items or the chemicals, and that's the lovely idea. to answer your question, that do we need to have the facility for that or not for informal sector? The answer is, think it's a good idea to have that, and how to do it. We have been do some pilot project by implement the kind of co-working space for them, and we providing some the tool and also the PPE and so on to them. But anyway, it's still initial phase. We still have a long way to go for that. Yeah, that is my answer to that. And also the last one about the volume. I think volume is there, and we can see significantly increase this year. So in our project in Thailand now, we start this year already for the first line, and we already start to treatment for more than 7,000 tons of the PV, and we do see the even double in the next year onward.
Do I also need to add my comments? Yeah, so like my previous experience from Hong Kong, because I have had a lot of, I went to China also to the special solar panel recycling machine. I went to different. So of course, these two technologies are different, means thin film and monocrystalline. Monocrystalline and polycrystalline can be in one category, but the recycling infrastructure is totally different. But yes, so recycling infrastructure need incentives. So policies, if we talk about, so policies should not be only the extended producer responsibility. I think they should incentivize the recyclers also. So that's what it can bring the potential, because right now people are not ready to invest. Of course, we don't have volume, but the thing is, as Khun Phuket also mentioned, that we should start from the pilot. And pilot is something which we are promoting as a Circle PV Limited. We are actually promoting that it should be started from the pilot and not directly from the recycling, as you are promoting the reuse. But you know that reuse has its own consequences. You know that if you are using the second-hand solar panel, are the people ready? Because they will be, of course, comparing the cost of cheaper solar panel from the reuse. And then, of course, there is a lot of safety issues which comes into picture. So that is one thing which I am saying that is very dangerous when we are talking about the second life of solar panel. But yes, it should be started from there, the reuse. Second is that pilot level study, where there should be some strategy which can bring the knowledge to the people of about repair, when to reuse, and when to recycle, because it is very complicated. Solar supply chain is not, it is complicated. You know that we have third-party installers, we have suppliers involved. So from Hong Kong scenario, we have generally more about suppliers, third-party installers, so which are related to PV manufacturers, but they are the stakeholders from Hong Kong. So we need to think about that. So can we connect them onto one link? That is one thing. So that is what I will be ending from now, means of course policies, and then of course pilot survey and pilot level of involvement which Hong Kong can start. Of course, starting from the small collection will be helpful, because you know people are thinking that when our solar panel waste is there, what to think? They don't know. So if some initiative, maybe from the CCIL help and some other stakeholders, we can start it from the collections, and we can start it from the pilot survey. Yeah. Thank you.
Okay, thank you, Ruth and Tanvi. And my apologies, I'm a bad timekeeper, so we overran a bit. Thank you, Jinlei. Thank you, Ruth. Thank you, Tanvi. Thank you, Ati, for sharing today. Tomorrow will be our last day and our third day for the conference, so be sure to join. And thank you, everyone, for participating today. I'll see you around.
Thank you.
Thank you.
All right.
Thank you so
Thank you
much
again,
for-
everyone. Bye.
Bye-bye.